Hey guys, I have a very exciting treat for you today. Today I am at the Microsoft Silicon Valley campus for the Triton conference. And for those of you that may not know what Triton is, you can think of it as a DSL built on top of Python that essentially acts as a replacement for CUDA. And the idea is that we want to be able to write custom kernels that run on the GPU at blazing fast speeds in a much more easier fashion. Because there's a lot of overhead when it comes to learning CUDA, when it comes to learning how exactly the GPUs work, how warps, how scheduling, how the different thread blocks interact with each other, and Triton aims to simplify away a lot of that. Again, because the syntax is very Pythonic. So in exchange for a little bit of a performance cost, the productivity of the developer theoretically increases by a much larger magnitude. So perhaps the biggest difference or simplification that Triton makes in relation to CUDA is that CUDA operates on separate threads, whereas Triton abstracts away threads, and now the basic primitive that you operate on are blocks, which are essentially multiple threads at once. So given that there's a lot of inter-thread interaction that needs to occur in CUDA and properly managed, Triton simplification greatly makes the developer experience much more productive. So when it comes to writing custom kernels, let's say for flash attention with custom masks, or even like more optimized matrix multiplication kernels, using Triton can provide significant speedups relative to writing these operations from scratch in just CUDA. But today's conference is sharing all the progress that Triton has made over the past year and their future directions, and there's a lot of incredibly smart speakers all chatting about their experiences with Triton, and I'm very excited to take you guys through each of these talks. But just a heads up, I am a beginner at this stuff, so I'll also be learning right alongside you guys, and I'll be sharing what I'm able to distill away from this conference for you guys as well. So I'm very excited to start today. So the first thing on today's agenda was a introductory talk from two folks from OpenAI, and again, they were just kind of sharing a very broad overview about Triton and the progress that they had made over the past year. And then at the end, they also answered some questions that the audience members had. And then the next session is called GPU Mode, the State of Triton. So I'll let you guys know what that one was about. Awesome. So the first third of the conference is done. They had 3 separate sessions and I just had lunch. So the 3 sessions, the theme around them was the ecosystem. The first talk was by someone from the GPU mode community, previously called CUDA mode, and they were essentially sharing the impact that Triton has had on the open source community and kind of how and why Triton got so popular. They started off by outlining some of the issues with the C++ building process, and then they transitioned into how Triton with its kind of Pythonic syntax makes development incredibly easy. Towards the end, they talked about a lot of cool open source projects that are currently ongoing in the Triton community. So the second talk, it was about Helion, which is essentially another DSL, again for the kernel space, that actually is a layer below PyTorch but is a layer above Triton. So you write your kernels, again in a Pythonic syntax using Helion, and then it will, with its amazing auto tuner, generate thousands of different Triton kernels and then automatically choose the best one based on the shapes and other parameters that you can specify. So the idea here is to be a little bit more simpler than Triton, but to again give a little bit more flexibility that PyTorch may not grant. And a general theme that I've seen so far at this conference is that there's this Pareto frontier almost between developer productivity and then raw performance or GPU utilization. And all of these tools, whether it's CUDA or a Qt DSL or Triton or Helion or PyTorch, they're all at different points on this Pareto frontier. It's interesting that as a developer, you're able to then make trade-offs based on how productive you are or how advanced you are and what performance costs you're willing to incur. And based off of that, you're then able to choose the correct tooling. And I think that's really interesting. So Helion essentially sits a layer, like I said, above Triton. They also shared the really cool auto-tuning algorithm that they use as of right now. They're probably going to implement AI and LLMs and stuff into it. But right now they choose 100 different random configurations. Then they will choose the top 5 from those random 100. And then from each of those 5, they will essentially find the largest or the best performing kernel in each of the 5 areas. They call it hill climbing to the local minimum. And then you'll have 5 local minimums in this giant grid of possible kernels. kernels, and then they'll choose the best one out of like those possible 5. And I thought that was really interesting because again, it abstracts away a lot of the manual tuning that might be required when it comes to writing your own Triton kernel, such as like block size, loop size, and all of that stuff, which is very interesting. And then the final talk out of the 3 in this first third was about Proton, which is a Triton profiler, which again is very important because when you're writing all of these custom kernels, you need a way to be able to understand how fast your code is running. Proton naturally aims to solve that. They have a lot of tooling built in that world. I didn't get a chance to update you guys on the second and third part of the conference because I was chatting with some folks, but yeah, they were very cool. So let's jump right into what I listened to after lunch. So the first 2 talks right after lunch were by AMD and NVIDIA respectively, and an engineer from each company shared how they were optimizing Triton to work on their hardware. This outlines a very beautiful aspect of Triton where, as an ML engineer, I can write my code in Triton once, and then because of the work that AMD and NVIDIA are doing, my code will automatically run on each hardware. Now, obviously, writing specific code in CUDA and ROCm separately will yield even higher improvements, but the whole goal of Triton is to alleviate that burden. So both the engineers from NVIDIA and AMD talked about how Triton exploits some of the more newer features of each company's hardware, which I think is really cool, because again, like you write the code in Triton once, and like you can trust that like it's going to be pretty optimized. Like it's not going to be speed of light performance, obviously. So then the third talk after that was about Gluon. So I know we talked about Helion already before lunch, but Gluon actually is a layer underneath Triton. So Helion was a layer above Triton where you write Helion code and then that'll compile it to Triton. Gluon actually exposes some parts of the Triton compiler and gives even more control to the machine learning engineer. But again, it's between CUDA and Triton. So you can think of it again as another DSL, another way to write custom kernels. But if Triton's a little bit too limiting and you're not ready for CUDA, then Gluon, I guess, is kind of like the middle ground. It's like this entire like layer where it's like PyTorch and NumPy at the top, and then it's Helion, and then it's Triton, and then it would be Gluon, and then CUDA, or then PTX and SAS. And it's funny that there's so many different levels to this stack, because actually the one after Gluon was about TLX, which stands for like Triton Language Extension. So this one kind of is between Triton and Gluon. So this is still Triton, but now TLX opens up even more APIs that are specific to NVIDIA or AMD cards. So again, another way to like write custom kernels. So then after the TLX talk, someone from ByteDance actually talked about Triton Distributed, which is a project that like they're working on over there. And this is very interesting because again, it uses the simplicity and ease of writing Triton kernels and enables some more distributed features such as all reduce and like other communication primitives that exploit the network topologies that are common across NVIDIA and AMD clusters. And then the final talk I actually really enjoyed. This was about Liger Kernels, and Liger is a project started by some folks at LinkedIn, which, to be honest, as a machine learning engineer, I would not have expected LinkedIn to be contributing to this space. But yeah, it's actually really cool because I've used Liger kernels before, and you can think of them as like off-the-shelf kernels, off-the-shelf Triton kernels, otherwise they wouldn't be speaking here. So you can think of these as off-the-shelf Triton kernels that you can plug and play for like LLM inference or LLM training. So they were talking about how some of their kernels are like optimized loss functions that like reduce peak memory usage. Another important thing that they mentioned is why Liger kernels, when like Torch compile automatically generates the necessary Triton code. Well, the thing with Torch compile is it's not going to optimize peak memory usage. If you think about like flash attention, which I made a video about previously, running Torch compile on just the softmax or like the whole attention operation, it's not going to yield flash attention. And the reason for that is because compilers are smart, but they're not smart enough to find these very specific, nuanced, step-by-step memory operations that reduce peak memory usage. So the folks at LinkedIn and like the Liger community are doing this hard work for then us to have these kernels to just plug and play into our models. Overall though, this was a very good conference. I feel like it was incredibly technical. There were a lot of specific nuances that I don't think I even fully understood, and I want to go home and really just do like a thorough deep dive. I also want to revisit the Triton tutorials, but I think there's a couple main takeaways. First, well, I guess the first thing that's unrelated to anything technical is that I got into this conference for free. I think the conference itself was free. So if you're in the area, if you're a college student and you're looking for a good way to network, highly recommend conferences or opportunities such as this. There's actually a very interesting conversation I was having with some folks. There's this guy that I met who's in the robotics space. And when I mentioned that I work at Luma AI or I work on video generation, he was intrigued because for robotics, there's a lot of opportunities for like synthetic data generation or to generate new like out of distribution data, so you can almost validate that your robot's not gonna like freak out when it sees something that it's never seen before. But one thing he pointed out was a lot of modern image and video generation models, they prioritize one subject in frame, whereas for their training data, they want something much more chaotic. He mentioned the example of like a warehouse where there's boxes everywhere, there's other robots moving around, and you want your robot to be able to handle these environments. And then he asked, why is that the case? Why do image and video generation models fail spectacularly at these specific like chaotic use cases? And it got me thinking, and I think the reason for this really is because of the training data. When you look at these video and image generation models, their goal is aesthetics. They're thinking about what's the most aesthetically pleasing image or video. Will this look good in a Hollywood production set? Will this look good as an ad? Will it actually sell the product that people want it to sell? And this distribution of training data is actually very orthogonal to the distribution that, like, let's say roboticists might actually need to train their robots. But it was a really interesting conversation, and I think these types of conversations are like enabled at conferences like this, where it's everyone who's a nerd who's thinking about these types of things. Anyways, that was a rant. But so that was like my first takeaway of just, it was a free conference. You should definitely like exploit these types of opportunities. But second, there's a lot of room for optimizations that like Torch Compile simply does not grant you. However, you also don't need to be scared of CUDA to start to learn about or use some of these optimizations. I think it's very powerful to have something like Triton, which makes the world of custom kernels much more accessible and almost as like a stepping stone, where you can write most of your custom kernels in Triton or like Helion, and then for the ultra optimized parts that are like super mission critical, you can even step down with like TLX or Gluon, and then for the ultra serious moments you would use like CUDA, or if you're really crazy, like you would write like PTX or something like that. But I think having all of these libraries at different layers in the stack, it may seem overwhelming at first, but the goal here isn't to use all of them. The goal is to maximize the amount of options that you have to then choose where in the stack you want to operate in. And again, this is a function of the cost you're willing to incur, the skills you have, and honestly the time that you're willing to invest into this. Because if you have an infinite number of all three, you should obviously just write assembly code, but you know, no one's doing that. Yeah, so overall, very interesting experience. Definitely outlined a lot of new topics I want to learn about. Lots of chatter about like the new Blackwell architecture, AMD's latest MI350Xs, and I think it's very exciting. And given that, like, I don't think the NVIDIA moat's going to be lasting forever. Like, other card vendors are going to be stepping in. And if these card vendors are able to now support a Triton backend, it makes the cost for compute go much lower because there's going to be a larger supply of card providers. And I think that's really powerful. Those are just kind of like my raw thoughts. This entire video was very unscripted. I didn't really know this morning what to expect from this conference. But yeah, if you guys enjoyed this, let me know. I'd love to hear about it down below. And if you'd like to see more conferences or more vlogs at conferences such as this, like, let me know. I have the PyTorch one coming this week. Actually, it's tomorrow, but it depends on when I end up posting this video. I think these conferences are a great way to learn about what's coming out in the next 6 to 12 months even. If you guys made it to the end, thank you so much for watching, and hope to see you guys next time. Bye-bye.